Now that we've known about the coefficient of variation and how to solve it, let us now try to answer some sample problems. Given the data set with a mean of 50 and a standard deviation of 5, what is the coefficient of variation? We have A 0.10, B 0.20, C 0.05, and D 0.15. The formula, once again, is the standard deviation over the mean times 100%. This would give us 5 divided by 50 times 100%. So our CV is now equal to 10%, which is letter A. We have the next question, which is very similar. If the standard deviation of the dataset is 18 and the mean is 90, what is the coefficient of variation? A 0.10, B 0.15, C 0.20, or D 0.25. CV is equal to standard deviation over the mean times 100%, which would give us 18 over 90 times 100%. This is going to be doing some quick maths right now. This would give us 0.2, which is times 100%, which is 20%. Or in here, since it's in decimal format, it's 0.20, which is letter C. Consider the following problem. Given the data 100, 110, 90, 105, and 95, find the coefficient of variation. We haven't been given the standard deviation or the mean, so we have to solve them for ourselves. So again, CV is equal to the standard deviation over the mean times 100%. So to get the standard deviation, we have the formula, the square root of the summation of x minus the mean squared over n minus 1. Then for the mean, we have the summation of x over n. We're not going to be solving this by hand anymore. I already made some quick calculations down here. Oops, you're not supposed to see question number 4, but let's proceed anyway. So just select some of these. Then you can see or calculate them for yourselves later on, but we are going to be referencing them now. So our mean is 100 and our standard deviation is 7.91. So our CV is going to be 7.91 over 100. We can simply move the decimal by 2, which is going to give us 0.07, sorry about that, 791. So the closest answer to our question is letter B, which is 0.10. So the answer for this question is B. On a similar note, we have another problem. Right here, a dataset contains the values 20, 22, 24, 26, and 28. Calculate the coefficient of variation. A is 0.10, B is 0.15, C is 0.20, and D is 0.25. CV is equal to the standard deviation over the mean times 100%. And then our standard deviation is equal to the summation of x minus the mean squared over n minus 1. For the mean, we have the summation of x over n. Again, we're not going to be computing for those values anymore. I already did that here. You can check for yourself later on if the calculations are, or if your calculations are the same. So we have the standard deviation, which is 3.16, and then we have the mean 24. So giving us a quick math right here, this is going to be 0.131 or 0.13. In this case, the closest option would be letter B, which is 0.15. Let us take a look at question number 5. A researcher collects the following data for 2 experiments, experiment A and experiment B. Is it necessary to use the coefficient of variation to compare the variability of these 2 datasets? A, yes, because the scales of measurement are different. B, no, because the scales of measurement are the same. C, because these means are different. And no, because the means are the same. Once again, we go back to our definition or the reason why we use the coefficient of variation. We use it when we are comparing data of 2 different scales. When we say 2 different scales of measurement, we look at magnitude and we look at the mean. So when we say magnitude, it is if one data or one set of data is greater than the other. In this case, yes, experiment B's data is bigger than the data set for experiment A. We also look at the mean. If we do a quick calculation for this one, experiment A would give us the mean of 12, and experiment B would give us a mean of 24. So looking at both magnitude and mean, the data set from experiment A and experiment B are different. So we are going to use the coefficient of variation. So we can already cross out B and D. No. A and D are both correct answers because A says because the scale of measurement are different, and then C, yes, because the means are different, which are both true. So the answer for this question are both A and C. Now let's take a look at question number 6. Given the following data on test scores from two different classes, class A and class B, is it necessary to use coefficient of variation to compare the variability of these two data sets? Again, when we are comparing two different data sets, we look at first the magnitude, and then the second one we look at the mean. Comparing the magnitude of class A and class B, we can't directly say that neither of the other is bigger or smaller since they are both very similar in values. So let's just say they are roughly the same. And then for the mean, doing a quick calculation, class A would give us the mean of 14, and class B would also give us a mean of 14. Since both the magnitude and the mean are the same, we can say that the scales of measurement for both class A and class B is the same, right? So we can already cross out B, and the correct answers would be A and C, since both of them are true for this question. Let us try to answer number 7. Dataset A has the following scores, and dataset B has the following scores. Which dataset has a higher coefficient of variation? Is it dataset A, dataset B? Both have the same coefficient of variation, or it cannot be determined. So let us first look for the coefficient of variation for both. I have already done some quick calculations for the mean and the standard deviation. Again, this formula for the coefficient of variation is the standard deviation over the mean times 100%. Okay, so let us compute 3.16 over 14. This would give us 0.225 or 0.23. This is for A. And then for B, we have 7.91 over 30. This one would give us 0.263 or simply 0.26. So looking at the coefficient of variation for both dataset A and dataset B, we can see that dataset B has a slightly higher coefficient of variation, which tells us that dataset B have a higher coefficient of variation. Let's now start with number 8. So dataset X has a mean of 50 and a standard deviation of 10. Dataset Y has a mean of 60 and a standard deviation of 15. Which one is a higher coefficient of variation? So we are given the mean and the standard deviations already. So CV once again is equal to the standard deviation over the mean times 100%. So we can quickly calculate for the coefficient of variation for X, which would give us 10 over 50 times 100%. This is 0.2 times 100, which is going to be 20%. CV for X. And then we also have the coefficient of variation for Y, which would give us 15 divided by 60 times 100%. This would give us 25%. So comparing both, we can already see that dataset Y has a higher coefficient of variation. So the answer is B. Okay, so we have question number 9. The teacher collected the following test scores from two classes, class A and class B. The teacher wants to know which class has more consistency in scores. Based on the coefficient of variation, which class is more consistent? A, B, both classes, or cannot be determined. So let us first look for the coefficient of variation for both data sets. PV is equal to the standard deviation divided by the mean times 100%. So let's first look for that. This is going to give us 7.91 over 80 times 100%. This is going to give us 9.89%. For the other one, this is going to be 7.91 over 75 times 100%, which is going to be 10.55%. So looking at the data sets and then considering the question which has more consistency, meaning which is less varied. So taking a look, class A has a lower variability or coefficient of variability than class B, which means that it is more consistent. So the answer for question number 9 is class A is more consistent. Now let us take a look at the last question, question number 10. A company collected the following sales data in thousands for 2 products over 5 months. The management wants to know which product sales are more volatile. Based on the coefficient of variation, which product has a higher volatility? I'm giving you some time to pause the video so you can try to answer the question yourself. Have you finished? Okay. If you have actually solved for the coefficient of variation, you have wasted your precious time because you can simply take a look at the data that is being presented to us. We have the same mean, right? So if you have the same mean, you can simply use the standard deviation given to compare since they are the same scale. So this is actually kind of like a trick question, which is very common in LET examination. So you have to be very careful at how you answer or how you analyze questions. Although the question itself asks based on the coefficient of variation, you can answer this very easily by taking a look at the mean and thinking, oh, they are the same scale. So I can just simply use the standard deviation to compare. And even if you actually solve for the coefficient of variation, it would give you the same result, which is that product Y is more volatile than product X. So the answer for 10 is boy. And that's it for the 10 questions for this series. I hope that you've learned something. And always be attentive on the test because there are many trick questions on the LET examination, such as this one. Thank you.